OS/2. IBM's OS/2 was once heralded as the future of personal computing, launched in 1987 as a joint venture with Microsoft before the partnership dissolved. This 32-bit operating system boasted superior multitasking capabilities, a graphical user interface, and robust memory management that far exceeded MS-DOS limitations. During its peak in the early 1990s, OS/2 offered features that wouldn't become standard in Windows for years, including preemptive multitasking and built-in networking. However, its decline came from poor marketing, limited software support, and Microsoft's aggressive promotion of Windows 95. Today, OS/2 exists mainly in specialized industrial applications and among dedicated enthusiasts who remember when OS/2 Warp represented the pinnacle of desktop innovation. BeOS. The BeOS emerged in the mid-1990s as a multimedia powerhouse, designed from the ground up for digital media creation and real-time performance. Created by former Apple executive Jean-Louis Gasset, this elegant operating system featured a unique modular kernel, pervasive multithreading, and a clean interface that made complex audio and video editing feel effortless. BeOS gained a devoted following among creative professionals who appreciated its stability and media handling capabilities that surpassed both Mac and Windows systems of the era. Unfortunately, its decline came from limited hardware support, lack of major software titles, and insufficient marketing budget to compete with established giants. While BeOS officially died in 2001, its spiritual successor Haiku keeps the dream alive for those who remember when desktop computing felt truly revolutionary. Amiga Workbench. The Amiga's Workbench operating system was nothing short of magical when it debuted in 1985, offering true multitasking, 4,096 color displays, and 4-channel stereo sound when most PCs were still beeping in monochrome. This groundbreaking system powered a computer that was years ahead of its time, becoming the darling of video producers, musicians, and gamers throughout the late 1980s and early 1990s. Workbench's intuitive interface and the Amiga's custom chips created multimedia experiences that seemed impossible on other platforms. However, Commodore's financial troubles, poor marketing decisions, and the rapid advancement of PC graphics cards led to its gradual decline. Today, Workbench lives on through emulation and dedicated communities who refuse to let this pioneering system be forgotten. NeXTSTEP. Steve Jobs' NeXTSTEP, launched in 1989, was arguably decades ahead of its time, featuring advanced object-oriented programming tools, stunning graphics, and innovative interface elements that wouldn't become mainstream for years. This Unix-based system introduced concepts like the dock, advanced text rendering, and integrated development environments that revolutionized software creation. NeXTSTEP found success in specialized markets, particularly in finance, education, and scientific research, where its power and stability justified its premium price. Its decline as a standalone system came from limited hardware options and high costs that kept it from mass adoption. Ironically, NeXTSTEP achieved ultimate victory when Apple acquired NeXT in 1997, with its DNA forming the foundation of macOS X and eventually influencing every Apple device we use today. Digital Research's CP/M. Before MS-DOS dominated personal computers, CP/M, Control Program for Microcomputers, ruled the early PC world throughout the late 1970s and early 1980s. Created by Gary Kildall at Digital Research, CP/M provided a standardized operating environment that allowed software to run across different hardware platforms, making it the de facto standard for business computers. This text-based system powered countless early PCs and established many conventions still used today, including file naming and command structures. CP/M's decline came when IBM chose MS-DOS for their PC instead of CP/M-86, largely due to pricing negotiations and availability issues. While CP/M faded by the mid-1980s, its influence on subsequent operating systems was profound, and vintage computer enthusiasts still celebrate its role as the grandfather of PC operating systems. QNX. QNX or QNX carved out a unique niche as a real-time operating system that could fit on a single floppy disk while providing full Unix-like functionality and exceptional reliability. Popular throughout the 1980s and 1990s, this microkernel-based system became the go-to choice for embedded systems, industrial control, and mission-critical applications where failure wasn't an option. QNX gained brief mainstream attention when it powered early tablet computers and was demonstrated running a complete GUI, web browser, and applications from just 1.44 megabytes. Its decline in the consumer market came from focusing too heavily on embedded applications while Windows and Linux captured desktop mindshare. Today, QNX survives in specialized applications like automotive systems and medical devices, a testament to its rock-solid engineering even if most users never knew they were experiencing it. GEM, Graphics Environment Manager. Digital Research's GEM brought graphical computing to DOS users years before Windows became viable, offering an elegant desktop metaphor with overlapping windows, icons, and mouse control starting in 1985. This system provided a Mac-like experience on PC hardware, complete with desktop accessories, file management, and graphics capabilities that seemed magical on early PCs. GEM found particular success on Atari computers, where it became the standard interface and powered a generation of desktop publishing and graphics applications. However, legal challenges from Apple over interface similarities, along with Microsoft's aggressive Windows development, gradually squeezed GEM out of the market. While it disappeared from most platforms by the early 1990s, GEM represented an important bridge between command-line computing and the graphical interfaces we take for granted today. GEOS, or Graphic Environment Operating System. Berkeley Softworks' GEOS transformed humble 8-bit computers like the Commodore 64 into surprisingly capable graphical workstations, offering a complete desktop environment with word processing, drawing programs, and file management starting in 1986. This remarkable system proved that sophisticated interfaces weren't limited to expensive computers, bringing Mac-style computing to machines costing a fraction of the price. GEOS gained a devoted following among home users who wanted professional-looking documents and graphics from their existing hardware. Its decline came as 16-bit computers became affordable and users migrated to more powerful platforms. GEOS later evolved into PC/GEOS for DOS systems, but ultimately couldn't compete with Windows' market dominance and extensive software library. RISC OS, originally developed by Acorn Computers for their ARM-based Archimedes systems in 1987, RISC OS offered blazing performance and innovative interface concepts that influenced modern computing in subtle but important ways. This system introduced cooperative multitasking, 3-button mouse conventions, and drag-and-drop file operations that felt futuristic compared to contemporary systems. RISC OS excelled in educational markets, particularly in the UK, where its speed and stability made it popular in schools throughout the 1990s. However, limited software availability and Acorn's eventual exit from the computer business led to its commercial decline. While RISC OS continues development as an open-source project and still has dedicated users, it remains a fascinating example of alternative computing approaches that never achieved mainstream success. Plan 9 from Bell Labs. Bell Labs Plan 9, first released in 1995, represented a radical reimagining of operating system design, treating everything as files distributed across networks and extending Unix concepts to their logical extreme. This research system introduced revolutionary ideas about distributed computing, UTF-8 text encoding, and namespace management that were decades ahead of their time. Plan 9 attracted computer science researchers and Unix enthusiasts who appreciated its elegant simplicity and powerful networking capabilities. However, its research-oriented nature, limited hardware support, and steep learning curve prevented mainstream adoption in a market increasingly dominated by user-friendly commercial systems. Today, Plan 9's influence lives on in various open-source projects and research systems, remembered by those who recognized it as a glimpse into what computing could have become.